I hope you guys are hanging in there as we keep pushing through the lecture on chain rules. So I have a new upgraded one. This is going to be a chain rule where I have two independent variables. So again, if I can draw you a picture, it's going to help. I'm going to tell you W splits off with X and Y, just like before. Now remember, before, all I did then was I said X went straight down to T, and that became a full derivative. Well, this time I'm now going to split it not just with a T, but also with an S, and same with Y, a T and an S. Okay? So, in this, there is no full derivative I can give you with W. I can ask for these two guys. I could say, hey, by the way, what's dW dt as a partial? If you notice, that's going to be slithering down here and here, along with that and that. It's not a full derivative because it's split the whole way through, and it's not complete because that's only half of the story. There's still S's involved. If you don't like what I'm saying, think of this one. If I said W, X, Y to T, I can say dW dt, and that's a full guy because dW dt would be grabbing this slide and this part, which happens to be all of that chain. But on the one I just showed you above, it's not all of that chain because I didn't talk to you at all about the S's. So on this, I'm only going to be able to give you a partial with dt, and I can also give you a partial, in terms of S. So it would be a partial W with a partial S, and that one would be slithering through same start, but break over here, same start, and break over there. Again, realize it's a partial because this top tree, or this top chain, the only way to have it complete is if I did both the blue and the green components, where this guy is a full derivative because all of the blue makes it dW dt. So in this, let's take a look at it again by trying to look at this tree and set up what they could be. So again, if I had the W goes to X, goes to Y, goes to T, goes to S, goes to T, and goes to S. Okay, let's take a look at one. I could say the partial of W with the partial of T. Well, if I want to do that, I'm going to go down this one. That's a partial of W with the partial of S, or not S, partial of T, times this piece. I'll just keep it all one color, which is going to be the partial of X with the partial of T. Guys, I am really sorry. I'm getting tired. It's a long day on a Tuesday afternoon. Let me just start that again. I don't want to re-record this. This is the partial of W in terms of the partial of X times the partial of X in terms of the partial of T plus, now you got to break over to this side. That would be the partial of W over the partial of Y times that partial, which is the partial of Y over the partial of T. There's one guy. Notice everything here is about partials because the tree keeps splitting, or the chain keeps splitting. And on this one, I can do the partial of W in terms of S. Notice the first line is the same, so it's going to be partial of W with the partial of x times the partial of x now in terms of s plus the partial of w over the partial of y times the partial of y over the partial of s. And hopefully you keep noticing every single time I try and teach you this, I show you the chain. As long as you see the chain, you're going to be totally fine in taking the derivatives. Understand the concept, the math is easy. So if we take a look at one, here it comes. Here, use the chain rule to find the partial of w with s and the partial of w with t. Here's kind of the example of it. I still like on any problem, I still set up my chain. I start with w splits with x and y because it does. And x is related to t and s, and y is related to t and s. So when I do this, I'm going to do, let's do the partial of w, partial of t. Here comes the first guy. That's the partial of w with x. So what's that derivative? It's 2y. Now I got to do the partial of x with the partial of t. Well, that derivative is 2t. I'm going to add on to that the second part of the branch where I go through the y components. So this guy is the partial of w with y, which would just be 2x, times the partial of y with t. So I go down that part of the branch. And that guy, who remembers how to do s over t? How do I do that derivative? Hopefully you guys are okay with negative s over t squared. Calc one thing. I'd move the t up. So I'd say it's st to the negative 1. And I would take it that way. Remember the s is just a constant. Okay? Hey, there's my partial. I could plug in an x, a y, or a t, and you could solve and get the actual partial value. If I wanted the partial of w in terms of partial of s, just go down it. Here we go. That guy's the same, 2y. But now I'm doing x to s, which is just 2s, plus, okay, let's see. Now I got to go down the w to x, or sorry, w to y, which is just 2x again. And then I need to go from the y to the s. Now here it's s over t. Remember, the t is just a number. So this guy is just 1 over t. So there's the partials. You can use them. You can apply them. But right now I'm just trying to teach you to get used to how to take the derivatives. The math is easy as long as you know basic derivative skills like this one here. It's as long as you can set up the chain. So hopefully you're okay with that one. I just upgraded the chain again. So now let's try the next thing that can happen with the chain rule, which will be all about implicit differentiation, which hopefully you remember from Calc 1.